Alpha particles, beta particles, and gamma radiation are three types of ionizing radiation. They differ in their properties and behavior, as described below. Alpha particles. Alpha particles are positively charged particles made up of 2 protons and 2 neutrons, identical to the nucleus of a helium atom. They are relatively heavy and have low penetrating power, meaning they can be stopped by a sheet of paper or a few centimeters of air. However, they can be highly damaging if they are ingested or inhaled because they can ionize atoms in living tissue. Alpha particles are commonly emitted by heavy radioactive isotopes such as uranium and plutonium. Beta particles. Beta particles are high-energy electrons or positrons emitted by certain radioactive isotopes. They have a smaller mass than alpha particles and are negatively charged. They can penetrate further than alpha particles, but can still be stopped by a few millimeters of aluminum. Beta particles can cause damage to living tissue, but to a lesser extent than alpha particles. Beta particles are commonly emitted by radioactive isotopes such as carbon-14 and strontium-90. Gamma radiation. Gamma radiation consists of high-energy photons emitted by the decay of a radioactive nucleus. Gamma rays have no mass or charge and are highly penetrating, meaning they can pass through several centimeters of lead or concrete. They can cause significant damage to living tissue and are a significant health hazard in nuclear power plants and other settings where radioactive materials are present. Gamma rays are commonly emitted alongside alpha or beta particles during radioactive decay. Overall, each type of radiation has its unique characteristics, and their potential for harm depends on factors such as energy, dose, and duration of exposure. Effect of transverse magnetic field on a radioactive material. The effect of a transverse magnetic field on alpha particle, beta particle and gamma radiation varies depending on the properties of the radiation and the strength of the magnetic field. Alpha particle. When a magnetic field is applied perpendicular to the path of an alpha particle, the particle will experience a force perpendicular to its velocity vector, causing it to curve in its path. This effect is known as the Lorentz force, and it can cause alpha particles to deviate from their normal trajectories. However, since alpha particles are relatively heavy and have a low velocity, they are less affected by a magnetic field compared to beta and gamma radiation. Beta particle. When a magnetic field is applied perpendicular to the path of a beta particle, the particle will experience a force perpendicular to its velocity vector, causing it to curve in its path. This effect is also known as the Lorentz force, and it can cause beta particles to deviate from their normal trajectories. However, since beta particles are lighter and have a higher velocity compared to alpha particles, they are more affected by a magnetic field. Gamma radiation. Gamma radiation is a form of electromagnetic radiation consisting of high-energy photons. Since photons have no charge, they are not affected by a magnetic field. In summary, the effect of a transverse magnetic field on alpha, beta, and gamma radiation varies depending on the properties of the radiation and the strength of the magnetic field. Alpha particles are less affected. Beta particles are more affected. And gamma radiation is not affected at all.